So before we start this part of the lesson, remember, you have already learned how to solve a system of equations. That's still what we're doing here. We're still solving a system of equations. You've learned to do it by graphing. So for all of these problems, you could graph the two lines, solve them for y and graph, and find where that solution is. Okay, this is just another method to solve if you didn't have a piece of technology to graph and or wanted to try a different method. This method is called the substitution method. All right, the substitution method is a method of solving systems of the equation. Substitution is a method for solving system of equation that involves isolating a variable, so getting either x or y by itself, in order to substitute or replace that into the other equation, which means we only have one type of variable, and when we have one variable in one equation, we can solve for that particular value. Okay, there's a lot of steps that go on for this, but let's make sure we understand what substituting means. And when we're substituting today, you're going to have to use a bunch of parentheses. We're going to be multiplying a lot of numbers in front of these parentheses, so we got to make sure that we plug anything in, replace anything, substitute anything with parentheses. So this first problem here, just like to make sure we know what substitute means, it says substitute x equal to 8 into this whole equation, which means anywhere I see x, I'm going to replace it with an 8, but I'm going to put that 8 in parentheses because I have to make sure that I'm still multiplying or adding, subtracting, whatever I'm doing to that number 8, the same as if it were a letter. Cool, we've substituted it. Now, here's what we're going to be doing though. This time, on the second example, it says for y, I want you to substitute both the 4 and the x. X plus 4, the whole expression gets replaced in there. Anywhere you see a y. Now, why is it the y this time and not the x? Because it literally says y is 4 plus x. So I'm going to leave all of the x's alone, but everywhere I saw that I saw a y a second ago, I'm going to instead write 4 plus x in parentheses. So notice, just a second ago, this was y, and now I changed it to 4 plus x. I have substituted that expression in. All right, our first example to solve a system of equations by substitution. We are looking for the full solution here. So coordinate, yes, this problem's already done for you because I wanted you to have a nice example written down. Step 1, we need to isolate a variable in one equation. No big deal. So I'm going to take the first equation up here, and I'm going to solve it for y. Pretty easy steps. We subtract 2x on both sides. We write down what we have left. We divide by the number in front of y for each and every piece. And once we do each of those little division problems, we're left with y equal to x plus 3, which means that in the next equation, the y is going to be replaced with x plus 3. That's what we're going to substitute in. Okay, so if you check out the next equation, just a second ago, that other equation said x plus 3y equal to 5. Okay, that's this equation right here, the other equation. So I took that y value that was there just a second ago, and I replaced it with that x plus 3 that we got from step 1, because y is x plus 3, so I replaced it. I've substituted it in. Okay, and then I'm just going to solve this equation. We've got a number in front of parentheses, so I'm going to distribute. That means multiply. 3 times x is 3x. 3 times 3 is 9. I'm actually using inverse operation steps here, but from this point forward, if you wanted to use the box method, if you know what that is, you could totally start the box method here, but I'm using inverse operations on this example. In inverse operations, we combine our like terms. 1x plus 3x is 4x's. We're going to subtract 9 from both sides to isolate the x term. We'd have 4x equal to negative 4. I'm going to divide by 4, and we'd have that x is equal to negative 1. Now, I have one of the values of my solution, but remember, solutions are coordinate pairs, so I'm not done when I just found one of them. But the next part is super simple. We're just going to substitute back in that value of 1, negative 1, into our red equation, the equation that we solved for. So I'm going to take y equals x plus 3, but instead of x, I'm going to plug in that negative 1. And check it, negative 1 plus 3, that's just 2. So now I know the output for y, and I know that the solution is the coordinate 1, 2. Because remember, it asked me for the whole solution here, not just one of the values. Okay, so the steps are, again, isolate a variable. Once you've got it isolated, plug it in to the other equation. This is a regular box method equation. So we distribute, and then we solve for x using inverse operations or the box method. And we've got half of our answer. Woohoo! We take that half of the answer, we plug it back in to the step 1 equation to get the second part of my solution. Let's do another practice problem on the back. Okay, now this one doesn't have the steps there listed there for you, but we got this. It is, again, asking me for the whole solution, so I know I'm looking for a coordinate pair. But do you notice that this is already my red equation and that it's already solved for y? Sweet. All I need to do is take that red equation and plug it into this other equation. Now, am I going to put it on the x or on the y? Yeah, because this equation says y equals, you're going to plug that in on the y. So here I go. Okay, so I have 4x plus 2y, but I'm going to leave a giant parentheses open on that y because I'm substituting in the red equation, x minus 13. We distribute, so we're going to have 2 times x and 2 times negative 13, which would be 4x plus 2x minus 26 equal to 10. Again, at this point, if you're a box method person, do the box method. But for everybody else, we're going to combine like terms. It's right here. This is 6x. We're going to add 26 to both sides to isolate the x term. And we're going to divide by the coefficient of x. Voila. Yay. However, I'm not completely finished. Remember, that's only half of my whole answer. I need a coordinate pair. So I'm going to take that isolated equation, the red equation, and instead of x, I'm going to plug in that value I just got for x, which was 6. And 6 minus 13, that's negative 7. So I have both parts of my solution. To make this our final answer, we just make it a coordinate pair, 6, negative 7. Now, if I wasn't sure that this was correct, what could I do to check this answer? Yeah, you've already have one of them solved for y. Just solve this other equation for y and graph it. These would be 2 lines, and their solution, the point where they cross, would be the coordinate 6, negative 7. And that's how you know you got this question correct. Awesome. One more example together. It says, what is the value of x in the solution to the system of equations? Okay, so I'm looking only for x this time. I need to solve one of these equations for y, or solve one of these equations for one of the variables at least, so that I can start substituting things in. Do notice that the second equation right here, you see how it has this x right here just like chilling by itself? That means it's going to be probably the easiest to solve for because it doesn't have a coefficient. It's just a 1x. So what we're going to do is we're going to take x minus 3y equal to negative 6, and we're actually going to solve it for x. Wild. Because that x is going to be by itself. That's what we'll substitute in. So I do the inverse operation of minus 3y, which is plus 3y. I'd have x equal to 3y minus 6. That is my isolated equation. This means that I'm going to replace the x in the other equation that I haven't touched yet with the expression 3y minus 6. So here we go, I'm going to do that. So I normally have 2x, but instead of 2x, I'm going to leave that open parentheses so that I can replace it or substitute in the 3y minus 6. At this point, I only have one type of letter left. I can solve for that letter using the box method or inverse operations. I'm going to be showing inverse operations. 6y and 4y are on the same side of the equal sign, so I can combine like terms there. That's 10y. I'm going to use inverse operations to move the 12 to the other side of the equal sign. Then I have 10y equal to 13 plus 12, that's 25. Divide by 10, divide by 10. I'd get that y is equal to 2.5. We'll let that be a decimal since that's a nice pretty decimal. Awesome. Now, that's the y value of my answer, but remember, this particular question asked me for the x, so I'm not quite done yet. I need to take this value of x and I need to plug it into that red original equation. So what am I plugging in for y? I'm plugging in that 2.5. So let's do that. If we have x equal to 3 times 2.5, well, 3 times 2.5 is 7.5. And 7.5 minus 6, switching colors here, 7.5 minus 6, that's going to be 1.5. So I have my whole coordinate of 1.5 comma 2.5. However, this particular question asks me what's the x value. So I'm really only looking for 1.5. That's the x value in my solution. So substitution, again, is just another method for us to solve systems of equations when we're not wanting to graph it. It involves isolating an equation, isolating a letter, either x or y, substituting that expression in, it's called substitution, solving that single variable equation using inverse operations or the box method, and then using that number back in the isolated expression to get the missing value. And then you have your coordinate. And that's solving by substitution.